Hudson Grey here. Today, we're venturing into the vast unknown beyond the usual folklore to explore some of the most fascinating Earth-like planets in the known universe. Humanity has always looked to the stars for answers. From ancient civilizations mapping the skies to modern scientists using advanced telescopes, the search for a world like our own, another Earth, continues to ignite our imaginations. The planets we're exploring today: Kepler 4, 5, 2b, Kepler 186f, Proxima Centauri b, and the TRAPPIST-1 system, each hold the tantalizing possibility of life. These distant worlds have caught the attention of researchers because of their potential to support water, atmosphere, and life itself. But what makes them so intriguing? What do we know about these worlds, and what kind of life could thrive on them? Let's begin our journey with Kepler 4, 5, 2b. The so-called cousin of Earth lies about 1,400 light-years away in the constellation Cygnus. It orbits within the habitable zone of a star remarkably similar to our own Sun. Discovered in 2015, Kepler 4, 5, 2b is often referred to as Earth's bigger, older cousin. Why? Because its host star is similar to the Sun, but it's about 1.5 billion years older. This gives us a glimpse into what our planet might look like in the distant future. Kepler 452b is larger than Earth by about 60%, making it a super-Earth. And although its surface conditions remain unknown, the planet could have a thick atmosphere, active volcanism, and even vast oceans. If life exists here, it might have had billions of years longer to evolve than life on Earth. Now, imagine what that could mean for potential life forms. Life on Kepler 4, 5, 2b might be entirely different from what we know. Larger creatures, perhaps, adapted to higher gravity and atmospheric pressure. And what about plants? With an older star and perhaps more stable conditions, the flora on this planet could be massive and hardy, evolving to withstand eons of environmental changes. Some scientists even speculate that complex, intelligent life could thrive here, benefiting from the billions of years of stable conditions provided by an older, sun-like star. It's fascinating to imagine an entire ecosystem. Life forms taller, stronger, and more ancient than anything we know. Now, let's move 500 light-years closer to home, to Kepler 186f. This planet was a breakthrough discovery, the first Earth-sized planet found within the habitable zone of its star. Kepler 186f orbits a dim, red dwarf star, much cooler than our Sun, but it's still far enough from the star to potentially have liquid water. This planet may be smaller and darker than Earth, but its conditions could support life. Because of the low energy output from its star, life here, if it exists, could resemble extremophiles on Earth, microorganisms that thrive in the harshest environments, like deep ocean vents or in the frozen ice caps. With less light, photosynthesis might evolve differently here. Perhaps life on Kepler 186f would rely on chemical energy rather than sunlight, creating a world where life forms glow-in-the-dark, bioluminescent creatures feeding off the planet's chemical resources. Some scientists theorize that Kepler 186f could even be a water world, with vast oceans covering its surface. Imagine an entire planet dominated by aquatic life, massive creatures adapted to dark, deep waters, existing in a state of perpetual twilight. Could these creatures have evolved intelligence within their underwater worlds, forming complex societies beneath the waves, never needing to reach the surface? It's both a scientific mystery and a tantalizing thought. If life exists on Kepler 186f, it would likely be so alien to our own, yet it might have followed a similar evolutionary path. facing challenges, adapting, and thriving in the darkness of its oceans. Next, we travel closer to home, relatively speaking, to Proxima Centauri b. At just over 4 light-years away, Proxima Centauri b is the closest potentially habitable exoplanet to Earth. Proxima Centauri b, life in the shadow of a red dwarf. Orbiting the faint red dwarf star Proxima Centauri, this planet is located within the star's habitable zone, where liquid water could exist. But here's the twist. Because it orbits so close to its star, Proxima b is likely tidally locked. This means one side of the planet always faces the star, locked in eternal daylight, while the other side is trapped in perpetual darkness. The narrow band between these two extremes, the Terminator line, could be the most hospitable region, with temperatures mild enough for water to remain liquid. Imagine a world where life has evolved to survive in this thin strip of twilight. Creatures adapted to the blazing heat on one side, or the freezing cold on the other, could exist in the harshest environments. In the twilight zone, life might be more temperate, with flora and fauna uniquely adapted to constant low light. But Proxima b's proximity to its star could be a double-edged sword. Red dwarfs are known for their intense stellar flares, which could strip away the planet's atmosphere, leaving it exposed to radiation. However, if Proxima b has a strong magnetic field or a thick atmosphere, life could still survive, protected from these stellar outbursts. The thought of intelligent life in these conditions is intriguing. Could a species evolve to protect itself against a hostile star? What kind of shelters or underground systems would such life create to survive these flare-ups? Maybe their civilization exists below ground, thriving in a planet-wide network of tunnels, shielded from the surface's dangers. Or perhaps they've evolved bioshields, organisms with thick exoskeletons or regenerative abilities to withstand radiation. It's a haunting idea, an alien world where survival depends on constant vigilance against the deadly whims of the nearest star. The TRAPPIST-1 system, 7 worlds, endless possibilities. Lastly, we arrive at one of the most exciting discoveries in recent years, the TRAPPIST-1 system. Located about 40 light-years from Earth, this system boasts 7 Earth-sized planets, 3 of which are in the habitable zone. Each planet is tightly packed around its cool, dim star, with orbital periods ranging from just 1.5 to 13 days. The closeness of these planets to each other creates a fascinating dynamic. From the surface of any one of these worlds, the neighboring planets would appear massive in the sky, almost like our own moon. The TRAPPIST-1 system offers a unique opportunity to study multiple, potentially habitable worlds at once. Each planet could have vastly different environments, even though they orbit the same star. What makes this system so captivating is that its star, a dim red dwarf, emits only a fraction of the energy that our Sun does, meaning the planets in the habitable zone are much closer to their star than Earth is to the Sun. Could one of these planets host liquid water? Perhaps under icy surfaces like Europa or Enceladus in our own solar system? If we consider the conditions on these worlds, it opens up endless possibilities for life forms. Maybe on one planet, life thrives under a thick, insulating atmosphere, with towering, spore-producing organisms that feed off geothermal energy. On another, creatures could evolve to navigate the vast ice oceans beneath their planet's frozen surface. Or perhaps there's life on the surface, creatures that have adapted to the faint light of a red dwarf. What would their eyes look like? Massive, capable of capturing every photon of light in their dim world? Or Maybe these beings rely on senses beyond sight to navigate their environment. TRAPPIST-1 invites endless speculation. 7 worlds, each with its own mysteries. Could life have taken hold on one or many? It's enough to stir the imagination of anyone fascinated by the unknown. And as we continue our search for life beyond Earth, the TRAPPIST-1 system remains a beacon of hope. A reminder that in the vast, cold darkness of space, there could be countless worlds teeming with life, just waiting to be discovered. We've only begun to scratch the surface of what could be out there. Each of these planets, Kepler 452b, Kepler 186f, Proxima Centauri b, and the TRAPPIST-1 system, presents its own set of possibilities, a canvas upon which we can imagine the extraordinary forms life might take. What awaits us in the vastness of space? As our technology improves, perhaps one day we'll have answers. For now, the possibilities remain endless and the search continues. This has been the top 4 most livable Earth-like planets. I hope you enjoyed. I'm Hudson Grey. Please subscribe for more deep dives. Thank you. You are all greatly appreciated.